Good afternoon, ladies and gentlemen. We'll be starting in a moment if you want to take your seats. The session this afternoon is going to look at real-time streaming and other information services that are being made available. The first presentation that we have comes from two sessions that will be from PSNC, one more about the streaming side and one about library services, information services that are being provided. So we'll start off with Miroslav Czernak from PSNC.
Good afternoon, ladies and gentlemen. I would like to present you ITVP platform, which allows to deliver interactive TV services over IP networks. First, I would like to start with a short video, which will be played on the screen. Just a second.
Dawno, dawno temu, kiedy nad Wisłą żyli Wiślanie, nad Bugiem Burzanie, a nad Gopłem Goplanie, a każde plemię miało swoich bogów, panował okrutny popiel, którego zjadły myszy.
This is a long time movie, but probably you are interested how it's played. I will show you that. Do you have such devices? Yeah. This one is quite new. It allows full-screen movie playing with 640 per 100 pixels. It uses Wi-Fi to access the platform and play the movie wherever you are and wherever you have the access to Wi-Fi. I can also show you that it is possible to reach the stream from the conference with such device. We'll choose from the catalog. Sorry for horizontal view. Here we get the stream from Aula Magna. Yeah, buffering. The stream is 500 kilobits per second, so we have to wait for a while. Then can see it.
The stream is 500 kilobits per second, so...
Okay. But of course, such devices are not only the ones you're using to access multimedia. So let's now consider you are sitting at home in front of your plasma screen, having access to your... Sorry. To your multimedia home center. This is a set-top box powered with Windows Media Center Edition which allows you also to access services from the ITVP platform. You can, of course, browse your music, videos, and use special application to run ITVP services. Sorry, the interface is in Polish, but I will describe you shortly what is accessible. We have access to live streams from television as well as catalog of content. Let's play the movie we've seen before, just before on the iPad. We choose from the catalog. Choose the format and play it. Of course, we can view it in full screen mode.
Dawno, dawno temu, kiedy
It's quite more effective to use it than iPad viewing, but it's also a different point of view scenario. Menu and find live stream. And maybe we will choose also the stream from the conference. Yeah. Can you see yourself? Yeah. Okay. Yeah. Let's get back. And of course, this is not only the one scenario, but also we can use standard PC to access the service. Okay. Now we see the standard portal, which allows to access interactive TV services for users with standard PCs. We have catalog services very similar than accessible from set-top box or from iPad, which we can manage differently for each access channel. And for example, we can see also the movie from the films, the same as in the set-top box or iPad. Let's choose the middle quality. Okay, I will bring the mic to have the voice. Okay.
Dawno, dawno temu, kiedy nad Wisłą żyli Wiślanie, nad Bugiem
That's the integration
Burzanie,
of services
a nad
and
Gopłem
access
Kotlanie,
channels, which is possible
a
through
każde plemię miało
different
swoich bogów,
networks,
panował
different
okrutny
user
popiel,
devices,
którego zjadł
and the one and only one system which allows all the for the services. I will try to describe you briefly how it works, what are the main components, and what are the possibilities delivered through this system. First of all, I would like also to show you live streams, which on PC are also available through time shifting. That enables us to watch the live channel with a 2-hour buffer, which means when we are late for the news or our favorite match, sorry, we can get back in the live through EPG information.
Tylko tu i teraz. SMS o treści 13.
Of course, it's always
Na razie żywca nie
accessible
brakuje, ale
for
kolejek przed punktami skupu nie ma.
both
Pojedyncze
services,
zakłady, jeśli
which are
potrzebują
also
więcej
available
tuczników, lekko
in the
podnoszą
portal.
cenę, to wystarczy,
So
by zachęcić
everybody
rolników do sprzedaży.
can try,
Inne obniżają cenniki, bo żywca mają poddostatki.
everybody
Ceny w kraju
can
wahania
use
cen bardzo małe,
the
w
best
granicach
services for
10
him.
do 20.
Okay. There's also another feature which is quite interesting for the content providers, which allows them to provide the users with commercials. The system can play the audio and video commercials, which are manageable from the content provider side, as well can support context-driven commercials, which are presented during the stream presentation. Here you have a short clip about paintings. After that, the live show begins. Of course, user cannot switch off the commercial, so we can register if we viewed the visuals or not. Okay.
Monika Olejnik, prosto w oczy, witam Państwa, witam Panów, Piotr Pawnac, najwyższy
Now you will
kontroli,
see
generał Henryk
a commercial,
były szef zarządu wywiadu
context-driven commercial.
Panowie, jak to jest
Some
możliwe, żeby na
clubs
czele FOZ-u
which are
stał
presented
jeden
during
człowiek? Jak to jest możliwe,
video
żeby ten jeden
stream.
człowiek wyprowadził pieniądze? Jak to jest możliwe?
Another possibility is to add some subtitling, which is also managed by the content provider. I can show you an example from weather forecast. And here you can see some
Dobry wieczór Państwu,
subtitling
Marzena Słupkowska.
that is
Dziś ostatni
synchronized
dzień
with the
marca
stream.
i jak się okazuje, nie rozpieszczą nas ciepłem. Średnia
There are
temperatura
also
w marcu
some
wyniosła
commercials
niewiele
added
poniżej
here.
zera. Natomiast średnia wieloletnia to prawie 3 stopnie.
All right.
Początek marca był
I think
mroźny,
it's,
najzimniej było w Suwałkach.
most important
Zanotowano minus 21 stopni. Ale i
parts
tak nie
of
pobiło to
the
rekordu
user
minus
services
30
here,
stopni.
which I presented just in a few seconds now. So maybe let's switch to the presentation. I would like to tell you a few words about the motivations that we started work in Poland to deliver interactive TV environment based on IP. First, we wanted to deliver high-quality multimedia to the end users who use IP broadband connections, provide additional value-added services, and enable scenarios that will enable content providers to manage the content, to secure the content, and to have a possibility to create added value to their content in the archives. The users gained special services for content access, as well as searching and browsing the content that is published. As well, we see the many valuable features which can be used in the education. What is the most important for the content providers is the security of the content and the control who can view the content as well. That's why the system is equipped with digital rights management features and has dedicated components for license management. The system is structured in a few main components which are dedicated in the fields of content management and the content provider, which is content provider system. Then the content delivery system, which is based on Pioneer Network, which main feature is to deliver high-quality streams to the end users, as well interactive portals, which we understand as components which provide the users with services in different channels, as you could see on the PC or set-top box or iPad, personalized content to the end users, as well as the license management system, which takes care about the license control and access. The features which are most important from our point of view is that this platform allows to connect many content providers and many interactive portals, which means that anybody who wants to connect to this platform, from the technical point of view, can do it. It's also important for us that we can deliver, using this technology, content to different access channels. For now, we don't stream the content, we don't deliver content to mobile phones, but as you know, GSM or GPRS are not sufficient for that, and in Poland, UMTS is not ready for that now. We also provided in the system authentication and authorization, which connected with the digital rights management allows full control of the releasing the content and all the procedures. What is the most important for the content providers? They got the tools for content management, the workflow management, which I will tell you in a few seconds, as well as tools for managing their offer, so that they can interactively provide their services to the end users. The system uses MPEG 7 for the content description, which is also very important for the cooperation of different services and future developments. And during the project, there were designed and developed MPEG 4 AVC codecs dedicated for high-quality streaming. For now, we use Windows Media and Real Media as streaming platforms, but the architecture of the system is open, and we can incorporate any streaming solution that has some functions for control and management. One of our assumptions was that we will deliver streams between 750 and up to 1.5 megabit per second to the end user, which connected with the current status of encoding technology means high quality content with standard television. Now in a few words, I would like to present you the content provider system. The main tasks are content management and storage, because every content provider has lots of contents which are differently managed in different formats, so that they need tools to provide some kind of master copy which is stored in MPEG-2 and then encoded to internet available for streaming standards with codecs like Windows Media or Real or ITVP codecs. The content provider uses the tools in some kind of workflow where the content is described, then verified on technical side, on legal side, and then prepared for publication. The system supports also automatic encoding to different formats, as well as content encryption with license specification, which enables very easy specifying the policy, how the content will be released from the content provider. As well, we have some features which enable content distribution control, and the content provider may unpublish or just revoke the content from distribution, and nobody will access that after this. One of the important things in this system is to integrate with content provider backend systems, and of course it's different content providers, so it must be done every time we want to deploy such solution. During this project, we have prepared the integration with Polish national television systems to acquire some APG content, as well as information from for subtitling, so that it's quite ready to service to provide this information to the end users. Okay, the content delivery system, which was one of the main tasks of PSNC, is structured in two-level architecture, and has some regional data centers, which are placed in regional country level, and the proxy cache servers, which are placed at the ISPs and last mile operators. This means that when the content is acquired from the content provider, it is delivered to the first level of distribution and then to the proxy cache servers. Whenever the content is in the content delivery system, we don't have to ask the content provider for the content at the next user request. We just move the content from right RDC, which has the content, to the right proxy cache server. This architecture allows us to provide quite a good availability of the content, as well as reliable service to the end users. We developed some features to provide the live streams, which I showed you, as well as VOD and near video on demand services, which are natively supported in the system. As I said, currently we support Windows Media and Real for those who don't want to use Windows Media or don't have Windows Media Player. Okay. The most important features about the content delivery system is that we can optimize request routing from the users, so that load balance the system and direct the users to the best proxy cache which can serve the end user, which means that we can deliver quite a good quality of the stream to the end user. The system can work in two modes and controls the access policy of the end users. We have dedicated high-quality transmission for the end users who are placed, who are connected with the ISPs who have the proxy cache servers. As well, the system has the public webcast functionality designed for everybody who wants to view the streams And of course, this means that such events like TNC2005 conference or last time transmitted public sport events are accessible for anybody. The system allows content invalidation that which is quite important for the content providers, and secures the content access, secures the access to the content by the end users. This is done through a special security system with tickets and time-controlled information, which is included there. We have also tools for continuous monitoring of the system, the number of users, and reporting on the usage of the content. The license management system, which I've mentioned before, is used for supporting the license release to the end users, and it allows to specify different licensing scenarios. So you can provide the pay-per-view licenses, period controlled, for example, 1 month, or time controlled for 1 hour from getting the license. It's also possible to get the license in silent mode, which means the user doesn't have any interaction with the licensing system, but we can register the use of the content very precisely. The system allows also to take payments for the content, which can be done through credit card or SMS or some promotional codes. And here we can provide different methods of payment as needed. Moreover, it's integrated with portals. As I said, there can be many portals in the platform, and it's quite important for the end user to seamlessly get the license, not to log in every time, so that we have a single sign solution for this integration, which really easily allows to get the license and pay for that. I can show you the access to the content, which is controlled through the license management system. On the portal, we'll get some movie. This is the third part. Okay, we want to play that. The player opens, requests content from the content delivery system, and then we get the pop-up window with interface to the licensing system. We have to buy, okay, 1 point, and we play the content. It's very similar to the content which is not controlled with the content license management system, and very easy to use. Okay. Let's get back to the presentation. To summarize some interactive services that are possible through this system. First of all, we can serve the users with different devices, so PC, set-top box, or Pocket PC. As well, we have live and time-shifted live available in the system, VOD services, and near video on demand, which means that the user can request the content which is available on the content provider side, but stored in the archives. And then it is distributed on his request to the right proxy server This means that the user has to wait a while for access to the content, but this feature is, depends on the load of the system, so we can steer how much time the user should wait, because we can have users with better service quality and lower service quality, which means longer time of waiting. We also have personal video recording, which means that any channel which is EPG enabled, electronic program guide, which we have for the channel, that the user can request recording of the video from the live channel, for example, news or a long play video, and then whenever it is stored, he will be notified that it's available for viewing. I showed you also the context-driven commercials, which we see quite important, quite nice feature, and the metadata search, which enables us to search through the description of the some scenes of the content and access parts of that. Yeah. Now a few words on the project. It's a national funded project by the Polish State Committee for Scientific Research, and the Polish National Television is the main project partner. Cyfronet from Kraków as coordinator of the project. PSNC takes part in that. ATM, which is a firm from Poland, Institute of Micromechanics and Photonics, Warsaw Technical University, as well as Telecommunication Institute. Okay. This year we are finishing the research and development phase, and we will deploy it and release to the users. We expect that till the end of the year we will have Polish National Television archives available for the end users. Of course, not all, but some selection from that. Some regional departments of the national television, as well as Polish radio stations, live and AOD materials. The content delivery system will be deployed on the Pioneer network, and all the RDCs will be connected with 1 gigabit links. We'll have up to 30 proxy cache servers, which are currently operational, and each RDC has 7 terabytes of cache, and proxy cache has up to 1.4 terabytes. This means that we can cache up to 10,000 hours of standard content at the RDC, which means quite powerful. We'll deliver these services to the users in metropolitan area networks, universities, as well as to the ISPs and last mile operators, so that we expect quite a big access possibilities for the end users. Okay, and what will be the future? The future will be HD, which you probably have seen, but I can show you that we are ready now for that. The same portal with the catalog, some promotional material from Microsoft, delivered through the content delivery system.
fly in that airplane, I'm alive. And I'm part of that airplane, and that airplane's part of me. I'm absolutely in love with it, and I know I belong there.
Okay.
Thank you very much, Miroslav.
Thank you.
And I think you win the award for using every single piece of equipment that you have available
Yeah.
without anything breaking, which is an achievement. The next talk will be from Cezary Mazurek, which will look at a slightly different aspect of providing information, more on the library side. The demands we're getting for information, of course, there are so many links between video content, voice content, and library-type content that there seems not to make too much sense to make a distinction between some of this content somewhere. Just the delivery mechanisms need to be slightly different for the real-time solutions.
Okay, thank you, Steve. Ladies and gentlemen, welcome. Let me welcome you here in Poznań as one of the presenters from the local institutions. I can say that we are very happy to host this conference, and I should also mention that what Mirek didn't say maybe, that all the streaming which is here from the TERNA conference is streamed already through the system he's shown us, and we have dedicated 8 proxy cache systems for streaming, for handling users. But of course, this is the part of the system installed in the network, and other proxy caches which are operational serves normal users which are entering the national television website www.itvp.pl, and there's a content which they can access from the website, and they can use the same devices as well. Also, there may be some story from yesterday which shows that even we, developers of the platform, are not ready or are not thinking about the system like we could. At 5 p.m. we had the news on the national television on the channel 1 from our conference, and there was a very large material about the exhibition here, about the presentations. But I've got the phone from my wife like 5 minutes after that transmission, and I've called Mirek and said, listen, we had a chance to see it, but we missed this. And one of our colleagues said, well, we have time shifting, just take back half an hour and we can look at this once more. And that was really nice to see that it's working, and it was possible to start thinking about this like to be used in practice. Okay, I will not use those devices, but let me give you some approach for our research and development in Pioneer Network, basing on this program and basing on this project and other projects which are related to content management and information management. We are in the process of selecting the whole service set of those projects to build kind of information grid in the Pioneer Network to provide a set of services which might be used to build more complex applications. So in my presentation I will just enter the topic which is related to information grids. Then I will present you some examples of information services we have in Pioneer. It's a digital library service and streaming media service. I will skip the whole part of interactive television because you just saw it. And I will provide our approach for architecture for information grid and state some examples of applications. So since many years we are very active in grid research. We have many grid initiatives in Poland and around the world. There are many initiatives succeeded in developing and deployment of different grid components. And as you know, the driving force for this research and development were the scientific applications, the applications which demanded very smart computing infrastructure. And what is our thesis is that the emerging information environments, like digital content environments, must take advantage of grid services and tools to enable efficient information management and access, just like computational grids do this for computing applications. So within the Pioneer program, there has been realized systems, projects for last 5 years in the area of information and digital content as well. There is a digital library framework and there are digital library installations. There's an audio streaming system which we've started with. There's a data management system for grids, computing grids. There's also an interactive television system which we have just seen. So as far as digital library services are concerned, the first part of content and information services, we have currently 3 installations of digital libraries in Toruń and Poznań and Wrocław. There are regional digital libraries, and there's also some configuration and I would say test beds in Zielona Góra and Białystok, and we have some testing groups in Warsaw and Łódź, as well as there are several places which want to start building such a system, like digital library in other places like Szczecin, Gliwice, Częstochowa. And those installations I've just mentioned are based on digital library framework, which was developed in the Pioneer program. And we've started in 1999. I've presented several times this framework on Terena conference and others. But for last 2 years, we've been successful in deployment of this framework. We have Wielkopolska Digital Library, which you can access. We have the University of Technology Digital Library Wrocław, and we've just installed a regional digital library in Toruń. The digital library framework provides the services which might be considered to be embedded in the grid information grid architecture. Because this platform is completely distributed, multi-tier, and portable, and it provides support for multiple content types. We have opportunity to build a collection of this content, and also for particular objects, for particular publications, the framework provides the resources versioning system. Of course, the most important issue in content management is the metadata, and we provide as many schemes for metadata as users wish, like Dublin Core, MARC, RDF, and might be many others. There are many searching mechanisms, and searching might be provided also on text or hidden text basis. And also there's extended access management for LDAP and single sign-on mechanisms. So the architecture which allows us to start thinking about the building basing on this software, the information grid environment, is like on this picture. And we have here the kind of broker of services. This is the system this is the part of the system which allows to the digital library environment to gather the information about the localization of services, about the users and rights which are available, which are required to access the services, and several servers which might be installed in different parts of the network for communication, for handling the searching, for handling the information about the users and authentication, just for the storing the real content, for management and storing the metadata, and for handling the distributed search functions through Open Archive Initiative protocol for metadata harvesting. So this is the system which is open for external installations and for services like in the information grid architecture. The whole system is accessible through the web servers, but also the application, editors might use the application designed for the publishing and for the content update. So each service can be deployed on different hosts, and that's the first approach which we can compare to computational grids. Services does not need know about their localization, and also they can communicate with each other through events, through sending and receiving events. That's the implementations can be easily replaced, so that's not very related services as far as implementation is concerned. And also services can access each other if they are, of course, authorized to do this. External services can access digital library system through RMI or through Open Archive Initiative protocol, as I mentioned. And that's the first part of content-related services. There are digital libraries. Now, the second project group or second activity has begun with the streaming services for audio. And because that's the streaming session, so I will bring some information about the system, which came before the interactive television project has started, but it's still operating for the audio streaming. We have, of course, it's audio streaming, not steaming, so that's still operating. We have 12 servers operating in 10 locations to transmit the audio from 14 radio stations, and there's 40 streams available, and that's the one huge platform centrally managed to provide users with a streamed from the nearest or the best localization. We use the IceCast 2 servers, and that's the main reason that we didn't move this platform to interactive television platform. And there are a set of services which are blocked by this system, which might be considered as the part of information grid. There are users are redirected to best servers based on the availability of stream on particular server, on a current load on server, and on the network distance to user. And the information about topology of the network is gathered from BGP. So there are those 12 radio stations which we are transmitting, and there's also from time to time we transmit some events. I mean only audio, but we have constant cooperation with Poznań Football Club to transmit all matches from Lech Poznań Stadium, and there were also last weekend there were also National Youth Christian meeting in Lednica where we have transmitted the audio from this event. And the load we have is like average 800 listeners per day. Maximum we had 1,200 simultaneous listeners, and the load is spread between the stations, because there are stations for young people, for teenagers, for our generation, and also some news stations. So that's different profiles of stations. For instance, Talk FM station, it's the news station, and on this statistic from 19th of April, we see the point of choosing the Papa in Rome, in Vatican. It was like 6:48 when the peak of users came. It was very visible when users came to the stream. Okay, other services which I will just mention because there were two presentations we had here on Terena is data management services from Progress Project. Yesterday Michał Kosiedowski presented the idea, and content distribution services from interactive television. There are also services which we plan to include in the whole information grid infrastructure. Those services Mirek just described, so I will just remind them. So the idea of all these sets of services provided by the mentioned systems is to bring them together in one system called information grid, into one architecture, which will allow to construct a more advanced information application and its access from specialized portals. How we will do this? First of all, we will group services within the additional layer, which is called service provider. We get this concept from the Progress Project, and we are going to port this to information grid. And the content management services are independent of computational resources management services, so that's kind of a separate provision of services. Every system provides, every low-level system provides the brokerage service, like this digital library, which manages its resources. In that case, it's managed also information or content delivery. And service provider communicates with many brokers and provides abstractive description for objects or complex processes, which are managed by high-level services in the systems. Service provider also is accessible from many portals, so the system services, the grid services might be used by, the same grid services might be used by different portal applications. What are brokers' tasks? Brokers' tasks are access interfaces to information grid services, accessing information interfaces to information grid services. They enable the handling task in an efficient way in the system. So the distributed resources are used in an efficient way, like in the interactive television system, and they communicate with each other. So the architecture, which was also presented yesterday, so I will just recall it, it's like that we have several systems which are related to the content or computing, like that one here, and each of the system provides the services through its broker to the service provider layer, and any portal can use different services from a different service provider, and the service provider is responsible for storing of the actual context of the service. And this architecture might be then projected for the virtual organization construction for solving many problems from like e-medicine, e-content, or entertainment, to provide the services, not only computing services, but also information retrieval, or to combine all those services in a kind of virtual organization for solved particular problem in the information grid. Example of information grid applications, just to mention that we have bioinformatics computational applications in this architecture already, that was presented yesterday. We are working on the telemedicine applications, but also the architecture will be used in other projects which we are starting in the Pioneer program. That's the access model to applications. So we have many portals. Those portals are based on one portlet framework, so we can reuse the portlets within this portals architecture, but on the below the portal framework we have the service provider layers and shared grid infrastructure for computing and information management. So concluding, the services for content management and delivery must be integrated and managed in the grid-like structure because they provide more for grid constructors, application developers, portal constructors, and operators of the network of networks. Grid constructors will be able to specialize their grids in the information access and management. Application developers will be able to use general services in the area of content management and delivery. And portal constructors, what is most important from the user point of view, will use an integrated service and content environments for efficient access to distributed information. And finally, operators will be able to build more complex application scenarios, and it will be based, we hope, on our Pioneer Information Grid services. Thank you very much for your kind attention.
Thank you, Cezary. We'll have a look at the end, see if we have time for any questions, but for the moment, we'll leave that. Of course, the presenters will be more than willing to answer questions over a cup of coffee during the break. A reminder that we have the conference dinner this evening, and whether you're making your own way there or through transport, there will be people outside the venue to direct you towards the actual location where we'll be having our food, etc. So keep an eye out for the terrain signs when you're looking around this evening. So the final talk we have in the session this afternoon is from Dirk Kutscher, and looking a little bit at some of the standardization, or trying to move towards a standard framework for finding these the vast quantity of media that we currently have available, but we're starting to find it very difficult to find what we're looking for. Thank you, Dirk.
Yeah, thank you, Steve. Okay, this talk is not so much on the multimedia streaming side, but more on the service announcement or multimedia session announcement side. So I'll talk about internet media guides. This is joint work with Jörg Ott from Helsinki. And I'm going to talk about a technology that might not only change the way we deal with multimedia session announcement, but might also be useful for advancing service description or service location in general. So the outline is as follows. I'll start with a brief motivation. Why are we looking at this today again? And then I'll talk quite a bit about the concepts of internet media guides, as I assume this might be new to most of you. And then I'll present some sample applications, some experiences we had so far, and come to my conclusions. Okay, yeah, can I get a show of hands? Who knows what's an application? Okay, not that much, not many. Okay, that is SDR, one of the famous MBone tools. The MBone is the multicast backbone of the internet, and overlay a multicast network for providing multicast connectivity to remote sites. And when we started in the internet to do multimedia conferencing, we used the MBone as a distribution platform, and just send out sessions by allocating multicast groups, port numbers, and then broadcast our content. And in order to find sessions, conferences, lectures, and so on, we used session announcements. So there was a protocol called the Session Announcement Protocol, SAP, that used STP, the Session Description Protocol, for describing sessions. And essentially, those descriptions were multicast. So it was a push distribution model, had a single well-defined type of service, and yeah, SAP is essentially one-to-many distribution, relied on soft-state paradigms, so it just used periodic retransmissions. It had the notion of scopes, just relying on the IP multicast semantics, so we had TTL scoping in the beginning and admin scopes in the end. It was specified to be independent of the actual description format, but in fact it has mainly or only been used with STP so far. And this is what STP looks like today. This is essentially a simple text-based description format for providing standalone descriptions of multimedia sessions. It has a technical section, the blue part, and also some amount of meta information about the session, so about the author, the subject, and also some scheduling information. When is this going to be multicast? So SDP clearly was designed for a SAP-based announcement in the internet. Today we also use it for IP telephony, setting up our SIP sessions, but essentially it was designed for SAP. And the assumption was that those announcements could be received by all potential viewers, and we use the same network and distribution scope for both the announcement and the actual session. When we look at SAP SDP today, well, the first observation we already had in the beginning is that no one really uses it anymore. So it's not really popular, and it's not commercially used. So one of the reasons is, of course, that it's closely tied to the IP multicast-based session model. So IP multicast itself hasn't taken that off as we had all expected. And SAP SDP is also a bit limited because it has only one distribution scheme and just the announcement model and one specific type of service. It can only convey multimedia session information. At least it's only used like that. So multicast itself has not been successful, and SAP is, to be honest, rather an experimental protocol, and was probably most often used for actually debugging purposes, for not really in large-scale or commercial activities. So to summarize, to cope with current demands, SAP SDP is a bit too limited. It's not really appropriate as a general solution for distributing session information, and one of the reasons is that it's closely linked to the IP world and to the IP multicast world. When we look at multimedia content in general today, we can notice that there are different forms of content, of course. There's live broadcast, studio content, studio productions, canned programs, even video-on-demand file servers, web servers, maybe. And there's a set of heterogeneous end systems, and there are different distribution networks. There's the traditional physical delivery broadcasting network. We have 3G, 2.5G cell networks that are already being used for providing multimedia content. And of course, we have the fixed internet and other IP networks. And I think it's fair to say that all these will be more or less IP-based in the future. That's a clear trend towards that. But nevertheless, we still have to deal with the diversion of classic broadcasting and internet multimedia. So classic broadcasting is still a different animal compared to IP-based multimedia. I won't go through this in detail, but if you look at the data transmission, for example, in the IP world, we have mainly RTP, UDP-based real-time transmission, whereas in the broadcasting world, we have MPEG multiplex for the digital world, or even analog distribution. And that's also is reflected in the addressing schemes. So quite a different set of addressing requirements for broadcasting applications. And there's hope, there's an obvious trend towards IP in various areas, but still we have to deal with the existing broadcasting world and want to be able to describe, for example, sessions that are being aired by an DVB channel, for example. Okay, this kind of leads us to a goal we call platform or network independent content provision. And the idea is to make the same content available by different networks. So we have all these different convergent networks and want to be able to distribute one content without manipulating, without editing over different networks, and also want to broaden the meaning of content. Originally, you would think of audio-video broadcast, maybe web pages, but then there's also additional information like background information, statistics, maybe even advertisements that could qualify as contents. It should be considered as well. And in order to select or locate content, first of all, you have to identify it. So similar as in the web, for example, when we have URIs, we need some way of actually naming content and referring to it. And then, of course, we have to be able to find content. So we need metadata that describes what it actually is, how it can be accessed. And for broadcasting media, we also need to know when it will actually be broadcast. And as I said, we must provide for a set of different access methods, different networks, and network specifics. Okay, the application areas are probably DVB systems, 3G and 4G wireless communication, but also wireless LAN hotspots could actually qualify as access points for multimedia content, and of course the regular fixed internet. And what we also like to think of is to generalize the idea of content. So content could actually be viewed as a special case of service, like internet access, file distribution, or mobile commerce. All these are different services, including content provision, and would like to be able to describe these in different networks. So this is actually the foundation of the Internet Media Guide standardization effort that is currently being undertaken in the ITF. So it's a work item of the mMusic working group, and to define the work, maybe you can look at the content and the distribution aspect. So content-wise, an IMG is a collection of multimedia session descriptions. So it can be expressed using the existing description languages, SCP, SCPNG, or MPEG-7, what have you. And it can be used to describe a collection of multimedia sessions. Okay, that's not new. More interesting maybe is the distribution aspect. So the IMG must be developed to a potential large audience, similar to SEP, but not only via push, but also maybe using a pull-exit model. And it might also be required to allow receivers to be notified of changes. So it's not only a single one-to-many broadcasting model, but more a diverse approach to distribution. I think maybe it's fair to roughly compare IMGs to electronic program guides, so or to view them as generalized program guides. So they are generalized for arbitrary types of media, for different types of sessions and interactions. As I said, services can also be interesting to be described. And of course, they should be consumed on different classes of devices. Really important is the idea of providing multiple exit methods, like the physical traditional delivery, but also reliable broadcast multicast mechanisms, interactive retrieval, and also the notion of providing complete description, maybe of a whole bouquet of programs, but also to provide deltas, so the difference between maybe a longer complete description in order to save bandwidth, and also the notification model that you can just subscribe for interesting content descriptions and then be notified when there are changes, when your provider has changed the schedule, for example. IMGs should be network independent. That is relevant both for the delivery of IMGs, for the metadata and themselves, but also for the actual transmission of media. And the idea is also that I can have one IMG that relates to one well-known or one well-named content and can be used across different networks. Okay, now I'm going to dive into the IMG framework and start by presenting the different elements we are talking about. So first of all, there's the actual metadata, like maybe, as I said, arbitrary formats. Those are not specified by the IMG frameworks. They're just reusing what is there. Currently, they are using STP and STPNG. In order to be able to transport these different formats across the IMG transport methods, there's the notion of an IMG actually encapsulates the metadata and provides, so to say, meta information about the metadata. So where it is from and version information and so on. Okay, the fundamental model is that I have an IMG sender, an IMG receiver, and the sender can transport the IMG information about a mechanism. But there's also the model of IMG transceivers that can receive IMG information, maybe do some manipulations, filtering, what have you, and then forward the information to the actual receiver. And you can also have the model of having aggregations from multiple senders and maybe customizations to individual receivers. So this is the most abstract idea of transceivers. Now for actually conveying IMG information from sender to receiver, there are essentially, or there are exactly 4 different methods. So the one-to-many model is the IMG, it's called IMG announce, it's an IMG transport. So I have one announcer that uses broadcast, multicast mechanisms to just distribute IMG information to a set of receivers. And I can also use the more web-like model of a request response transaction where an IMG querier queries the resolver, as it's called, and receives the IMG answer called IMG resolve for the requested meta information. And then there's the subscribe notify model where I can subscribe for interesting meta information and then be notified upon changes or when there is information available. And this can also be handled in a variant where I subscribe and the notification does not contain the actual content of the IMG information, but just a pointer where this can be in a second step then requested and obtained. Okay, these are the 4 different IMG transport mechanisms, and there are 3 different IMG data types, so to say. So there's the notion of full IMG, as I said, so a whole collection of meta information, and there's the notion of delta information. So I can, in order to save bandwidth, as I said, just refer to an existing broadcast information and just send the diffs, and the receiver is able to patch the old version to the new version. And as a third, there's the notion of IMG pointers, so it can just reference existing or somewhere existing IMG meta information. Okay, to look at this with a protocol stack perspective, so with the IMG transport, point-to-multipoint and point-to-point, IMG announce is mainly done point-to-multipoint, but can also be done point-to-point. And across these different transports, we use IMG envelopes to encapsulate the respective metadata and can provide complete descriptions, delta descriptions, or even pointers. And the meta information itself is not specified by the IMG architecture. Okay, so far I've spoken of abstract IMG transport mechanisms, so there are actually specific protocols that are being used. So for the announce model, there's a Multicast protocol called Flute. Flute is one of the RNT protocols that provides file delivery over unidirectional transport. And it uses asynchronous layered coding, so one of the RMT building blocks. So it's essentially a file transport protocol for multicast. And there's an additional specification called Muppet, and Muppet is the IMG point-to-multipoint transport protocol that actually specifies how to use Flute to transport IMGs. For subscribe notify, there's a proposal to use SIP, the Session Initiation Protocol, which has a subscription notification framework, and yeah, for query resolve, naturally we use HTTP. And for all these different protocols, we use a single IMG URI model that allows us to map individual protocols for actual processing, so we actually know how to access a specific media guide. The IMG envelope is essentially a container for metadata, so it specifies this is a complete IMG, this is a delta, or this is a pointer, and it's completely independent of the specific format. So it's actually a wrapper and tells the application how to interpret the specific IMG information. So it contains generic management information, identification, versioning, and so on. Provides the content type, and should probably also provide security information. This is currently not in the specification, but it's debated, and it's probably needed to provide authentic content descriptions and other security features. Okay, implementations. We have been implementing this. We have two implementations. The first one is actually a generic multi-channel distribution platform called Papageno, and it uses Fluid HTTP and will be using SIP for the notification model. And you can actually use this as a generic object distribution system. You can specify for multicast transfer, for example, which bandwidth, which retransmission interval, and so on, and can assign different channels. So announce the notification channel to the different objects, and this is being used by the actual IMG implementation that implements the IMG sender, transceiver, and receiver and proxy functions, provides for full IMG and data distribution. And we are currently using this to kind of extend the IMG specification, the IMG envelope specification. So one of our current activities there is to provide additional mechanisms for providing authenticity for IMGs that are processed by transceivers. There's a clear separation of the IMG implementation and the IMG semantics from the actual distribution platform. And what we have here is kind of a flexible toolbox that supports different metadata formats and is not linked to specific applications. So the first one is already available. The second one is work in progress. And we are applying these to different use cases. So one interesting use case for Fluid and for IMG is actually software distribution, where you send the update announcements with IMGs and describe where you can actually fetch new versions of software, or which channel you have to tune into to receive them, and then you just receive them via multicast using Fluid. An obvious application would be a SAP SDP gateway. What we have been doing in the past was a EPG distribution system. I have some details on this in another slide. And what we're currently working on is to distribute network service descriptions with IMGs. I also have a slide on this, and what we like to be doing in the future is to leverage IMGs for home entertainment and personal multimedia environments. So you don't obtain descriptions from some provider, but you actually have systems you are carrying around or in your living room that describe their resources using IMGs. Okay, the EPG distribution example. So most of you probably know TV network websites that provide their program schedule in HTML documents, and we have written a simple web scraping tool that obtains this from different providers and translates those to XML-TV. That's a simple XML-based format for program information. This is then distributed by an IMG sender, or is made available and put into an IMG envelope, and by some of the 3 different IMG mechanisms, finally is received by the IMG receiver, which is we have coupled to a home theater platform. So it's a program called Freevo that kind of emulates the popular commercial TiVo application, and you can actually consume the EPG information and present this to the user, and it actually registers with the IMG sender and receives updates automatically and so on. So this is a quite a nice application that actually useful already for us. So a set of first experiences. First of all, it's not that easy today to really find dynamical changing service descriptions. So most EPG content is rather static. So that may be caused by the current usage model where providers just put this on a web page once and they never look at it again and never change it. So maybe that changing it may just be too costly or is not worth the effort. So currently, therefore, we will say that just periodic multicast seems to be the right way to send this out to receivers. And then there are lots of interesting operational considerations, for example, for bootstrapping and multiplexing. So when you have a whole set of different providers and different services, how would you actually split this into multicast groups for sending out the IMG descriptions? So would you do this by provider, by service type, and how do you know which channel to join to receive your information you want to receive? So there's quite a lot of operational issues we are currently working on. And when we compare IMG to the set-based service guide distribution, it's interesting to know that IMGs can leverage MBON or multicast connectivity, but the good thing is that it's still workable without multicast, so it's quite useful for actually getting your descriptions to your consumers or receivers. So it may be an interesting driver for really deploying multimedia distribution in last mile point-to-multipoint use cases. Okay, so far we have focused on rather traditional content, so conveying EPG information or streaming in cellular networks. What we're currently doing is try to broaden the scope a bit, to cover services in a more general fashion, and also to consider the idea of having different regions and locations, and maybe to provide global service description and to enrich them for a given regional scope, to support personalized inquiries, and also to look at more business level issues like how is actually costs associated with the service description. So there are technical issues and there are rather business level issues, and I concentrate on the technical ones. So to give you an idea what we're currently thinking about is, imagine you have a set of IMG metadata that has global relevance and is being distributed by a set of IMG senders. So the first one may be Yahoo, and the second one may be AOL. And they obtain the metadata from somewhere, from different sources, maybe partially from the same sources, and send this out to centralized content brokers. So they subscribe to the different providers and aggregate the contents and hand this out via point-to-multipoint communication to local transceivers. And they could add local contents, so augment the received description, but they can also do filtering if something isn't really interesting in the local scope, and then finally hand out the program guide information using different IMG transports to service providers, and those could then finally feed this into your set-top box at home. So this has the notion of handing IMG contents to a different element in the chain, doing manipulations, aggregations, and so on, but still being able to kind of authenticate the original information. So to be sure that the Yahoo part of the description is still the original Yahoo part. So there's this is the IMG envelope work I mentioned before we are working on. So this is the idea of providing regional specialized service descriptions for IMGs. And one specific example we're working on is as a background, we're trying to address the issue of automatic service location and enrollment in access networks. So there are different services, internet access, telephony services, local content, and different service providers. You need to select one, a different access method for internet access, for example. And today, what you do is you kind of do a second guessing. There are multiple access methods, but you, as a user in wireless LAN, for example, you have to manually interfere with the system and select one and hope it's going to work. And there's no information about other networks. For example, in mobile scenarios, I would like to know where are other access points or other hotspots. That's not possible today. And we are trying to leverage the IMG work for describing network connectivity in general, so potential network connectivity. So users can receive descriptions over arbitrary interfaces for a region or for a given scope. And they also may receive or obtain local descriptions where different methods can then override the larger scope descriptions. So there's the notion of a geographic service location service description. So, and receivers will then be able to build maps of regions based on the IMG descriptions. I come to the conclusion. Okay, I've shown that network multimedia today is a different thing than 10 years ago. So it's a clearly heterogeneous environment. We need service guides beyond SAP and SDP. And the IMG framework can actually address this today's distribution network. So it covers the IP world, but also the traditional broadcasting world. So it could be a useful tool for promoting new network multimedia applications. And it can leverage the existing multicast infrastructure, but it's workable without. So it's a general approach for arbitrary applications. And quite interesting is the idea of providing data distribution and the aggregation filtering considerations. And yeah, what we're currently working on is to generalize content description as service description and apply IMGs for different applications. So data information about services, and to implement the idea of locally refining larger scope service descriptions. And that brings me to the end. Thank you.
Thank you. If we can just thank all of our speakers for this afternoon's session. And just one more thing, we won't take any questions at the moment. I'm conscious that we're heading up to the break, but I think the three speakers will be around to answer any questions. But just one other thing before we do disappear for coffee, if we can put our hands together and thank the staff here and PSNC for putting together all the technical services, because I think they have done an excellent job. Thank you very much.